everyone's awake. All right, so Mark's going to give us sort of an impromptu briefing on what's going on with the hurricane. So take it away, Mark.
Will this cover that, or I have to do both? Okay. All right. So I've been going over some stuff on the side there while listening to the talks and things like that. I'm showing a loop just to kind of show the last, it's essentially 5 days. Dorian comes into the picture, tracks up here to the northwest. One of the things is when you see the start of this loop, there was a lot of dry air through here, and some of it was coming off of Africa. John mentioned sunsets with Saharan dust. There was a two and a half week period where that dust was suppressing activity. One of the things that's kept this storm from kind of getting really going is that there's remnants of that dry air still in the Caribbean here. And, you know, if I stop the loop on the end, you can see that most of it's gone, but there is some dry air that works its way into the storm on the south side here. This has kept the storm from strengthening over the last 24 hours, although at the very end of the loop, you can see that there is an eye forming here in this loop, but there's some dry air in there, so it's probably not on the verge to really, you know, go to 2 or 3 quite yet. This has to get overwhelmed. One of the things you can see in the loop is there's good outflow all around the storm developing. It just needs to overwhelm this dry air that's kind of at the middle levels and circling still around part of the storm, and it's keeping it kind of in check for a little bit. A recon went in a little before the 11 o'clock update came out. It went through the eye twice. You can see the red is the pressure. You can also see that the wind's peaking in the eye walls. It found that the winds hadn't increased, basically verifying what satellite had shown. They'll go back, fly back into this afternoon. That 5 o'clock update that comes out will reassess what's going on in the middle of the storm there. He's going over to Spheric here, and I got a bunch of layers on here. I'll turn some of them off and on, but essentially what you're seeing here is that the storm has now moved well clear of any land areas. And you know, if I zoom in on it real quick here, you can see I have some layers loaded with lightning, and you know, the storm doesn't have much lightning around the center. We do see correlations with our lightning data flaring up near the eye wall before the storm intensifies. So that's one of the things we'll watch pretty closely, is if there's a burst of lightning that starts occurring in one of those eye wall bands, it's usually a pretty good sign that the storm's starting to strengthen there. I also have our pulse rad radar on here. It will show once it moves away from where the nearest radar out there is quite a ways away now. It's Puerto Rico has the nearest operational radar. There is one in the Virgin Islands here too, but so most of it we're picking up through the satellite imagery and then our lightning data as to what's going on with the storm there. I'm going to zoom back out here. I'm going to turn off a couple layers. Actually, I'm going to go straight over to this one. I got some model data on here. Conventionally, people call it the spaghetti plots. You know, one of the things that, you know, a layman can do with those is look where the grouping is, look for the consistency in, you know, where the models have grouped together. And if I zoom in, you know, a little bit here, you can see that through about 48 to 60 hours, the models are very well grouped. And then there's some models skewing off towards South Florida here. And there's a couple that turn kind of up toward the coast. The trends in the models have been it's slower. A few days ago, I think Monday it was, or Tuesday, landfall was for Sunday night. You know, the latest forecasts have it being mainly Monday, even Tuesday. And it's because of that slowing of the storm that the Hurricane Center, I believe, is saying more time over open water in a favorable environment, it could reach a Category 4 storm. One of the things to look at that I look at, I use this Tropical Tidbit site a lot. Some of you may use it as well, but you can see the grouping of the intensities of the different models, and you can see that, you know, there's a grouping right here that brings it kind of to a mid-Category 3. There's a few up here that bring it to a 4, and then there's a cluster down here that never really get it going past a 1. The Hurricane Center has decided they're going to go up in here. My experience with the Hurricane Center is they do skew a little bit to err on the side of caution. So that's why you see the Category 4 now right before landfall. The storm has slowed down. There are models showing that it could be a Cat 4, and so they're, you know, for the most part, probably discussing the fact that, you know, it's a good idea to make it a 4 for now. But one of the things, it's within 24 hours, there's a significant increase in the strengths of storm. So, you know, those are the things you watch for. If you don't see it happening, you know, you might figure that maybe these models might be a little bit more likely to occur. But this is, you know, everything that I'm looking at, you know, I think once that dry air gets out of there, which it seems to be happening with these forecast models, that there will be some good strengthening going. You know, and I'm going to go back to that loop once again here and pause it at the very end. And there's, you know, some pretty good convection on this side. And it looks like the eye's getting a little better organized here. So, and again, there's really nice outflow going all around this storm in about 3 out of the 4 quadrants. This one is still inhibited a bit, but it's starting to get together there. So, and then the latest global models. I've noticed that the global models are different than those hurricane track models. They are included in the spaghetti plots. Not always in all of them that you may look at. There's a lot of different models, but you know, the spaghetti plots show a lot of models that are tuned to handle hurricanes. The global model handles the global circulation better, and one of the things the global model is showing is that most of these global models have a track that is south of the going forecast track by the Hurricane Center. And I brought up a couple of these. That's the GFS. The Canadian 12Z model had the storm coming in around Fort Pierce. Now, one of the things it's doing is that there's a ridge, there's a high pressure that builds across North America, and you can see it in this satellite. There's a lot of dry air here. High pressure is building in there, and what it'll do is it'll build over top of the storm and kind of cap it and turn it toward the coast. And the global models are saying that's going to happen and be a little stronger and essentially turn the storm more to the west at a lower latitude. And so there's this tendency to have the landfall projected in north of Broward County up to maybe Fort Pierce. Also, the slowing down creates a lot of uncertainty. That's why I would say that at this point, anywhere from Miami up to Melbourne has some probability of maybe 20% or more that the landfall could be there. And that just shows that still outside of 3 days, the uncertainty is still significant. And then, most of the models do this, they build the ridge back over into more of a Bermuda high, and then the storm starts steering northwestward. So a lot of the models are showing that the storm makes landfall and then it kind of tracks up the middle of the state. The critical, as many of you know, factor here is that the north of that track is where the worst is. With that high pressure building to the north, there is, it's a little hard to see on here, but there's a decent pressure gradient from a high pressure that's over New England. And that will accentuate some of the winds on the north side. So storm surge potential is probably all the way up into Georgia because of that surface high pressure that's going to act. Here's the surface high, it shows better on here. This is a short range model. You can see this short range model also has it a landfall more toward Fort Lauderdale or so. This is one of the high resolution models. It only goes out to 84 hours, but it does get it to the landfall point. These models tend to be a little fast with the storm, so it has it on Sunday night, Sunday evening coming ashore down there. The Hurricane Center certainly has a different, a slower track there. So in the discussion from the Hurricane Center, many of you guys probably read this. Some of the reading between the lines that you can get is that they talk a bunch about previous advisories and if they're going to change a track or not. In this one, they note that there's quite a spread in the models after days 4 and day 5, and they make a point to say it's too soon to specify where on the coast the greatest impacts could occur. And that's mostly because of all the stuff I talked about earlier. There are considerations of noticing that the global models that would do the upper level pattern better are hinting at a landfall that could be a little further south. And if I go back to Spheric here and I zoom in with these model tracks on it, you can see that they're essentially going for, some of those global models are down here, Fort Lauderdale and Palm Beach. They updated the track kind of based on what they had because there's enough uncertainty that they don't want to change something. They don't want to do this flip-flop forecasting. They like to see a trend. And that's a reasonable thing to do. We do that with a lot of our forecasts, especially winter storms. You don't want to change a forecast and then have to go back to what you had. So if there's a radical change in some of the thinking, I would say at 5 o'clock, if they kind of go, especially if some of these hurricane models start coming in down in here, you'd see a tendency to maybe turn the storm, keep it on a more westerly track before it comes in, and then it would go up the coast there. So these are the probabilities that the statistical models put out. And if it's a little bit hard to see, but tropical storm force winds are the top line for each of these locations. And you can see that from Gainesville or even Jacksonville is close to 20% for tropical storm force winds, all the way south down to Key West. They're forecasting that winds a 20% chance or more. And then Fort Lauderdale and West Palm Beach and Fort Pierce have the highest probabilities right now based on the various models that they have in play there. But if you go back here, you can see that notably the cone covers all of Florida at day 4 to day 5 of where the storm could be. And that's reasonable in my opinion, but I think you have to focus on it's somewhere between Fort Lauderdale and Melbourne where the landfall would be. And so, at this point, if I would be forecasting this, I would say that we would be looking at forecasting, conditions to deteriorate through the day on Sunday, with the worst being mainly Monday. There are some signs that it could be a later Monday to even Tuesday based on the speed. So you're talking about a window of planning where you got to kind of think, well, it could be Sunday, the worst at landfall, and then inland here it could linger into Tuesday. There's a slowing that occurs on these turns, and that would be something that would drop excessive amounts of rain just north of the track, long periods of having really strong bands near the center, continuing over certain towns that would be along this to the right of this path. So it's what I would say is that the next couple updates are going to be very, very important. You get inside these short-range model ranges of 84 hours, and they begin to carry more weight. And I would say that a landfall would probably be maybe more toward south of the track that's in there currently, but this area here seems like where I would be leaning, and then some sort of turn to the northwest when it's over land. So there could be, will it be a category 1 here this far inland? If it's going slow, a lot of times these storms weaken a lot quicker. And then once they make a turn, they can really zip off quickly too. But they're all kind of showing a pretty slow track through here. So excessive rainfall would be the biggest problem in northeast Florida here, with squalls on the rain bands. Always to the right of the track, there's a tornado watch, and that's for short spin tornadoes that will spin down out of those bands. So they usually put that out just in front of the landfall by 3 or 4 hours, and then while the storm tracks, there'll be a tornado watch to the right of the track for a good couple days because of all the spin that's in the atmosphere with these storms. So that's what I kind of analyzed today. One thing of interest just right now outside is that there's a really good northeast flow going. There's a line of sea breeze cumulus that are kind of in there, and they are kind of moving through here right about now. And once that progresses down to the southwest, our weather around here, the chance for showers are dropping off considerably. So it's kind of an unusual day. There's really not a big chance for storms here today. But I know you're all focused on Dorian more than anything else. Does anyone have any questions on that?
The idea where Dorian's going after it hits Central Florida.
Well, it's looking less and less likely it's going to track out into the Gulf and re-strengthen. There's a lot of consensus that it's going to be spinning out in this area and then go back off the coast. It might strengthen again once it gets back out over the Gulf Stream, but the models that we're taking it across here and then maybe into Alabama or Mississippi, there's just really not anything showing that right now. Anyone else? All right.
Thank you, Mark. All right, next up we've got Dr. Michael Stock. He's done a lot of analysis over the last few weeks on historical alerting patterns, and he's got some great recommendations for everybody on how you should think about how you set your alerting distances. So here you go, Mike.
Thank you very much. So I'm Michael Stock. I am the Chief Lightning Scientist at Earth Networks, and for almost the last 20 years, I have been building instruments, deploying them, and basically just trying to figure out how lightning works. So that's what I'm going to be talking to you guys about today. Lightning, dangers, and you. Kind of briefly here, just to kind of give you an idea where I'm going. I'm not a big outline fan, but I'm going to start out with just how lightning works, just a really, really quick primer on that. And then I'm going to talk about why it's dangerous, and then we'll get into alerting. So, how lightning happens. We actually had a few discussions on this earlier today, but in Florida, you guys get a lot of these air mass storms, these pop-up storms, and they always start with the sun hitting the ground and causing an updraft, and that starts up a little bit of a cloud, and the cloud is not there on the screen, but I promise it's supposed to be. What happens is after that updraft gets going, that updraft is sort of your engine, and the particles in the cloud collide together, and when they collide, they separate with different charges. This is sort of like taking a balloon and rubbing it on your head and then sticking it on the wall, except that it's happening with water particles in the cloud. And because they're different weights, they separate out to different layers. And so you end up with these 3 layers vertically in the cloud, usually 3 layers, positive on the bottom, negative in the middle, and then positive up on the top again. So in science, we classify lightning into 2 categories, very, very, very broadly. We have 2 types, lightning that hits the ground and lightning that doesn't hit the ground. Very, very, very simple. The lightning that hits the ground, those are cloud-to-ground flashes, CGs. These are the things that everybody here is familiar with. They look very pretty. They also cause a lot of damage. So how these happen is in between the negative layer in the middle and the positive layer on the bottom, that's where the flash initiates. And so once that flash initiates, it expands into both charge layers, top and bottom. And then the bottom one, the charge layer on the bottom tends to be kind of small, and so the channel can continue moving down. Once that channel gets kind of close to the ground, then you start getting these upward leaders coming in from all of the objects that are close to the channels coming downwards. And one of those channels is going to connect. Once that happens, you get a bright flash that goes up the channel, and that's what you see. Before we move on too much farther, I want to talk about scale. We always think about, we display lightning as like this point on a map. And you always think about lightning and hit the ground, it hits a point, just one spot. But that's not really just a second. Icon Park Guest Internet is asking for some information. So this is cloud to grounds. These are 10% of the lightning flashes that happen. And then on to scale. So here's our picture. The width and height of these things is about 4 miles. So 4 miles from the ground up into that middle negative charge region, and then 4 miles across from one side of the flash to the other. And 4 miles is for like a garden variety, kind of boring cloud to ground flash. They get a lot bigger than that. So the biggest ones we've seen are hundreds of miles, cross states. So when you think about this point on the ground, that you're alerting on. Remember that the thing up in the sky is 4 miles across or more. So then we can talk about thunder real quick. So thunder is caused by the channel. The channel expands because it's so hot, and that causes a pressure wave, and that's the sound you hear. That sound travels to you at about 1 mile every 5 seconds. So if this flash is 4 miles across, that means that the thunder is going to last 20 seconds per flash. And that's actually true. So when you hear a rumbling, you hear a crack and a rumble, that's not a bunch of flashes, that's one flash that you're hearing. So the other type of lightning is the stuff that does not hit the ground. This is far more common. We call them broadly intracloud flashes, although intracloud flashes come in a lot of different varieties. The way these work is that they initiate in between the upper two layers. And once they initiate, they expand up in between those two layers, and that's basically it. You can still see them. They account for the vast majority of the lightning that happens. So about 90% of the flashes happen this way. They do produce light, so the cloud will brighten up, and they still make thunder, but the thunder is nowhere near as loud. In addition to these two broad categories, there's a whole lot of subcategories, and I'm not going to go into them because then I'll be talking about different types of lightning for an hour. But there is one more type that we really need to cover, and that is the bolt from the blue. And we want to talk about this because it affects lightning safety pretty heavily. They're very pretty, and they're also somewhat dangerous. So the way these things occur is they start out as an IC flash, as an in-cloud flash. And then for whatever reason, that channel there on top continues out of the cloud, outside into blue air, and then comes to ground. These flashes are not rare, but they're uncommon. And so I don't have really good statistics on exactly how many of them there are, but nominally, kind of sort of a bit hand wavy here, about 10% of CG flashes are of this type. So that means like 1% of all lightning is a bolt from the blue. So let's talk about safety. What does this mean to you? So if we just talk about, how dangerous is lightning, if you're struck by lightning, you have about a 10% chance of dying, which is less. Actually, that's lower than I thought it would be. The statistics on that are not so great because we have good numbers on how many people are killed by lightning, but the actual number of people who are struck is a bit more fuzzy because they don't end up going necessarily to the hospital, they don't necessarily report it. But estimated about 10% chance of dying. In the United States, first world country here, we have about 31 people per year who are killed by lightning. That's based on the last 10 years worth of statistics. And by far, Florida is the #1 place for lightning deaths in the United States. So if you go back 25 years, it was #1 for every year except for 2 of those years. So Florida is not ideal. In terms of demographics, if we take a look at who is struck by lightning, predominantly men, by a very, very large fraction. So the red bars here are men, the blue ones are women, primarily between ages 20 and 50. A pretty big range though. And what are they doing? Almost all of them, every single time we're outdoors. So if you actually look at what these categories are, we have boating, camping, heavy equipment, golfing, in the water, other, outside, and under a tree. And absolutely all of those but other requires you to be outside to do. So outside, not otherwise classified, is our most common way of being struck by lightning, closely followed by being outside under a tree. So do not be outside under a tree. And then, easier to be, that is right. So the third most common thing that people are doing is just being in Florida. This is Icon Park guest is asking for help again.
Just hit accept. It should go away. Is that what you hit last time too?
No, I hit X.
No, X.
So let's so you're struck by lightning. How does lightning kill you? Let me count the ways. There's 5 of them. Actually, notably absent on this list. So we have contact strikes, direct strikes, upward streamers, side splashes, and ground currents. And if you don't know what those are, I'm going to go into it here in just a moment. That's okay. Notably absent from this list is fire. This comes up because in places that are not the United States, lightning frequently will cause a fire, and then the fire is what kills you. On this list there, direct strike is rather uncommon. Not very many people are actually hit by lightning and killed. Most of them are indirect strikes. So let's go through these. Ground currents, most common way of being struck by lightning. Lightning hits the ground near you, and then the current actually travels through the surface of the earth. And so if you happen to be standing nearby, the current will go up one leg and down the other. This has a kill radius of about 30 feet, so if you're within about 30 feet of where the lightning flash strikes ground, this could affect you. Frequently, there are no external signs of injury, so you're essentially killed by cardiac arrest. So this is a photo of what this looks like. This is a golf course here. Lightning struck the grass and then burned channels into the grass. The other thing of note here is that for 4-legged animals, this is far more severe than it is for us. When it goes up one leg and down the other, that is passing through your midsection. But if you're a 4-legged creature, that goes right through your heart. And so that leads to somewhat disturbing headlines such as lightning kills 323 reindeer in Norway. Norway, yes. This happens for 2 reasons. One is that 4-legged thing. And then the other issue is that because it's raining and you have a whole bunch of animals, they cluster together for warmth and safety. And then if you happen to have lightning hit that cluster of animals, they all die. So next up on my list is a side splash. This is when lightning hits an object and then the channel jumps from the object to you. This is very common if you're standing under a tree. So please do not stand under trees. It is also fairly similar to contact flashes. I'm going to go ahead and group these together. In a contact flash, lightning hits an object that you're also touching. So back in the past when we had landlines, one of the things that people tended to be afraid of was if lightning hit the phone line and you were on the phone, then lightning could travel down that line and through the handset, and strike you. That's a bit less common, but next up I have a video. It's somewhat graphic of basically this happening. This is in Fort Myers, Florida, and our person here working in the plane, that is Austin Dunn, and the plane is struck by lightning. Lightning hit the tail of the plane, and then because he was working on a communication line on that plane, he was essentially struck as well. Following this, so Austin survived, as it turns out, but he suffered severe burns. He had burns on one hand and one foot, and over 6 months after this, he was still confined to a wheelchair. So definitely pretty severe. Next on our list of ways that lightning can kill you are upward leaders. This is about 10% of the fatalities that happen. We already talked about upward leaders when we were talking about cloud to grounds. We have this channel coming to ground, and if it is close enough to you, then you can launch an upward leader. They launch off trees, off buildings, and off people. So one of the interesting or terrifying things about this is that you do not have to be close to the strike point where it touches ground for this to happen. All you need to do is be in a high electric field or close to any channel of the lightning flash. So that means that you can be several miles away from where the lightning hit and still launch an upward leader. And those upward leaders can carry up to 200 amps, which is plenty enough to kill a person. This is a photograph of an upward leader off a building here. It's glowing because it's hot. So that's where the color is coming from. You have this hot gas that starts glowing. And a little bit more close to home, this is a photo of two young boys in California. They had gone up and hiked up to the top of a mountain, and their hair started standing on end, and so they took this picture. On the way down, the boy on the left was struck by lightning. He had burns on his back, and very likely this is an indirect strike caused by an upward leader. Very hard to confirm that, but very likely exactly what happened. And then our final method that lightning can kill you is a direct strike. This only counts for about 3% of lightning fatalities. Lightning comes down out of the cloud and strikes you personally. So more than likely, if lightning is going to hit you, it will not be direct. So what do you do? Well, if you listen to the National Weather Service, they have exactly one message that they want you to get, which is that if you can hear thunder, then you need to get to safety. So when thunder roars, go indoors. Seek shelter in a substantial building or hardtop vehicle. Wait for the storm to subside, then wait another 30 minutes, and then you can go back out. Which is a pretty good segue into lightning alerting, I think. This is our most unsophisticated lightning alerting method that you can possibly do. Now, one of the things I do want to mention is that when they say if you can hear thunder, they do not mean that if you can hear thunder and it's loud. They mean if you can hear thunder at all. Period, if you can hear it. The faintest rumbling thunder is enough. So for lightning alerts, we always define a lightning alert based on two basic parameters. We have the alert radius and then the all clear time. So the alert radius means that if lightning is within the alert, then we start the alert up, and then we wait until there is no lightning within that radius for a specified period of time. So what this looks like, here we have Florida and a point of interest. And so if we draw a circle around this point of interest, and then we have some lightning coming in, the lightning alert will fire here. That is a green flash to show you when the alert starts, and will continue. That red flash says that the object was struck by lightning. That would be our hit time. And then after the storm passes, we'll wait another all clear time period of time before we go ahead and say it's now safe to go outside. Which brings us back to that National Weather Service recommendation. When thunder roars, go indoors. So what is the alert radius and the all clear time? The all clear time there is pretty clear, that's 30 minutes. And the alert radius for hearing thunder is about 10 miles. So what we'd say here is that this is about equivalent to applying a 10-mile radius and 30-minute all clear time to your lightning alerts. So why do they say that? Why is it 10 miles and 30 minutes? And we'll go over 30 minutes here in some detail in a bit, but let's talk about 10 miles. So this was our lightning flash before. That's exactly why I drew the first time around. But here it hit the house. But it could have just as easily gone the other direction and hit this tree. And so when we go back and we think about the size of that lightning flash, the fact that it's 4 miles up in the cloud, at least 4 miles. And then we really think about it. We say it could actually come down anywhere inside that cloud. Basically, if you can hear thunder and you're under a cloud, you're definitely in striking position. Lightning can hit you. But the National Weather Service doesn't say, if you can hear thunder and you're under a cloud, go indoors. They say, if you can hear thunder, period, go indoors. And that's because of photos like this. This is that bolt from the blue here. And in this case, what they did is they went ahead and took a look at a whole bunch of these, and they measured how far out this channel can go from the side of the cloud. And it turns out that's up to 15 miles. And so to the National Weather Service, they say, if you can hear thunder, period, you're already in striking distance of that storm. Even if you're not under a cloud, one of these bolts from the blue can happen and strike you. So, great. Let's assume 10 miles in 30 minutes. The next obvious question is, if we implemented that here in Florida, just how many lightning alerts would we have? Now, a normal person would look at this and say, I don't know. But me, I'm a scientist, I have a lot of data, I went ahead and measured it. To measure it, I went ahead and picked 20 locations around Orange County, here near Orlando. I chose golf courses, but the locations aren't really very important, just 20 semi-random locations. And then I simulated lightning alerts for basically all alert radiuses and all clear times for 5 years worth of data. And then I counted them. So if we go ahead and use a 10-mile alert radius and a 30-minute all clear time, we can now talk about how many alerts you would see on average in a given year in Florida in Orange County. Now for you here who are not in Florida in Orange County, these statistics will not be quite right. So I think that's one of you. Two of you. So this will, to tell you what you guys already know, it turns out that you will get the largest number of alerts in Florida in July. That's when your lightning season peaks. It peaks in July. And the number of alerts that you're going to get in July is more than one alert per day, which is quite high. If we then go ahead and talk about how long each alert is, we look at the duration. The duration here I measured from the time of the first flash to the time of the last flash, so it does not include the all clear time for this duration on this plot. And we see that the storms tend to be between 60 minutes and 90 minutes. And we can talk about when they hit. And again, telling you what you guys already know, this is split up by season, summer, fall, spring, and winter. And the storms start picking up right around 3 p.m., 1500 UT, not UT, local. So 1500 local, and they peak around 8 p.m. They are minimum in the morning, they are maximum in the afternoon to evening. So if anybody here is, hopefully you guys are thinking basically the next question, which is what happens if we change the alert radius? So if we change the alert radius or the all clear time, I'm gonna go into both, but I'm not gonna try and hide the results from you. If we increase the alert radius, then you will increase your lead time, which is good. Unfortunately, you're also going to make your alert duration longer, and you're going to increase your false alarm rate. Both of those, all these things are true. And so the reason this is happening in graphic form is, imagine that we have two alert radiuses, a small one and a big one, and we have a storm that's off to our left and moving towards us. It's pretty clear here that the bigger alert radius has a bigger lead time, which is good. The problem is that if our storm is down here and we do the same thing, it's going to alert on the outer ring but not on the inner ring. So your false alarm rate is higher. It also takes longer for it to exit the ring, and so your durations are longer. So to put this into numbers, this is what it looks like. Here we have alert radius on the bottom and lead time on the top, and it grows linearly. So if you double your alert radius, you will double your lead time. And I was actually surprised at how linear it is. It is quite linear. I went out to about 17 and a half miles. I didn't go out to 50 miles. Apparently I should have. Similarly, we can talk about false alarm rate. This is actually probability of a strike hitting the target. Now, a strike hitting the target here, I had to put in some parameters. That means of the latitude longitude point that I had, it was within a quarter mile, 500 meters, which is pretty close. And then if your alert radius is very, very, very small, half a mile or so, that gets up to about a little higher than 10%. And that's because we're alerting on all lightning, in cloud and cloud to ground, whereas the hit is only for a cloud to ground flash hitting that location. If we go all the way out to 10 miles, I forgot to mention this, that red bar there, The red bar is always the National Weather Service recommendation in all of these figures. And so that's 10 miles in 30 minutes. And you can see that we have dropped, and going out past 10 miles, your alert radius, your false alarm rate is slowly getting worse. And the next thing we can talk about is, what about duration? I split this up into 3 bins this time around, and you can see that, roughly speaking, as your alert radius gets bigger, your duration gets longer, and again, it's linear. This isn't too surprising. Storms move kind of at a constant velocity, and so if you double the alert radius, it takes twice as long for the storm to go in one side and out the other. And in fact, that's exactly what you see. So if you take a look at 5 miles there, and then you look at 10 miles, the 10-mile bars are about twice as high. Now the 3 bins are what you would see if you were working from 9 to 5, working an afternoon shift from noon to 8, or if you were trying to run something 24/7. And so if we go ahead and take a look at the National Weather Service recommended alerts, the numbers are actually surprisingly significant. A 9 to 5 worker would see about 40 hours worth of alert time on average over the course of 1 year in Orange County, Florida. And that's like a whole week. And the afternoon shift worker from noon to 8, still 8-hour period of time, is about 3 times higher. I don't have an easy way of making that smaller, and I'm sure everybody here would like to make that smaller. So moving on to all clear time. We're going to do the same thing with all clear time. What if we change all clear time? What happens to our alerts? What happens? And so on. So here, if we reduce our all clear time, the good part is that our total duration gets shorter, but our false alarm rate will go up. It gets worse. The chance for the alert to resume right afterwards goes up, which is bad. And your lead times in the extreme cases will start to get shorter. So again, graphically, what's going on here? If we imagine that this is a timeline of lightning where we have 7 strokes. And if we alerted based on this simple 7-stroke storm with 10-minute all clear times, what we would have is 3 alerts that look like so. 1 for the first cluster, 1 for the second cluster, and 1 for the third. And if we use a 20-minute all clear time instead, we would do the same thing, except that now we would only have 2 alerts. And finally, if we did a longer all clear time of 30 minutes, we'd just have 1 alert for the entire system. And so for false alarm rate, what this means is, clearly for duration, the yellow one is longer in total duration than any of the other ones. For false alarm rate, we have 1 alert in yellow and we have 1 hit in yellow. So 100% of the alerts were correct, which is good. For orange, it drops down to 50% because we now have 2 separate alerts, and the way my counting would work is it would count that as a 50% hit rate. And for our grayish ones there that are a little hard to see, it falls even lower. It's about 30%, 33%, a third of them. Even more worrying is what happens when we take a look at the all clear time. And here, not all clear time, the lead time. So the amount of time from when you issue the alert to when the lightning flash happens. And for the long all clear times, or even just the reasonable all clear times, they're about the same. But if you go short enough and you're breaking up your storms enough, you're going to break up the beginning part before the flash actually comes and hits your location. And then your all clear time gets shorter than your lead time gets shorter than it should be. So let's go into numbers, like real numbers from the simulation. And this is the probability of a flash versus the all clear time. Again, the red bar is the National Weather Service recommendation, so that's 30 minutes. And what we see is that if you go up from 30 minutes, you have longer all clear times, things don't really improve. But if you go down, especially if you go down below 15 minutes, it starts dropping rapidly. So the probability that a lightning flash will happen inside that alert goes down. Your false alarm rate starts going up pretty drastically. Similarly, we can talk about how likely it is that the alert is to resume. So if you have an alert, what is the likelihood that 30 minutes after the all clear time, there's another alert? Now this is Florida. You guys have a lot of these pop-up storms, and they pop up in about 20 minutes or so. And so this will never go to zero. And in fact, it doesn't. You can see that even if you have very long all clear times, there's still a pretty high chance that another storm will happen, just because the probability of another storm on a day that already had a lightning storm is kind of high. But in general, it tails out. So going out past 30 minutes, again, doesn't get you a whole lot, although you're still at about 20% there. But going the other direction, making it shorter, the likelihood that you're going to have another storm goes up pretty quickly. And once you fall below about 15 minutes, it's going up very fast. And at 1 minute, not that I think anybody should have a 1 minute all clear time, you have a probability of a storm restarting of about 90%. Lead time. I mentioned that if you make the all clear time too short, you start eating into your lead time. So we're seeing the same basic thing happen again here. That at 30 minutes, if you go higher than 30 minutes, not much changes. Your lead time doesn't get better, really at all. But if you go backwards from 30 minutes, especially if you go backwards below about 15 minutes, your lead time starts getting shorter because you start splitting up your alerts for one storm you start splitting one storm into multiple alerts. And then we can talk about duration. Last time in duration, if you increased the alert radius and you doubled the alert radius, you would double your total duration. The good news is that's not true with all clear time. So it does increase linearly towards the end, but you can see that if we go from 15 minutes up to 30 minutes, it goes up, but it doesn't double, which is good. Our total duration here for our 9 to 5 people on the red bar is still about 40 hours though. That is actually basically all I had to show you today. I want to give you guys a real quick summary of what we were talking about. Lightning does not have to hit you to kill you. Direct strikes are pretty uncommon. In Florida, lightning danger is maximum in the summer in the afternoon. I know I'm telling you guys everything you already know, but the data definitely holds up with that. When thunder roars, go indoors. That is the National Weather Service message, and it's a good one. They are being reasonable. They are not being over-conservative. I think the National Weather Service would be more conservative if they could be. And that their message is geared towards the best thing that they think they can do for the general population. So if you're out and about and you do not have a lightning alerting system on your person and you hear thunder, you're already too close. In terms of my recommendations for what to use for alert radius and all clear time, I think reasonable numbers for most people are between 7 and 15 miles for the alert range, largely because you set the alert range to set your lead time. And you get, in Florida, definitely very much so, don't take this one outside of Florida. In Florida, you get about 1.5 minutes of lead time per mile of radius that you have. And so when you fall below about 7 miles of radius, you now have a lead time of less than 10 minutes. And that's maybe getting a little tight. And you can only do that if you have like a reasonable place to get to safety. And so if you're working with children on a field, you're going to need to increase that. And so all the way up at 15 miles, that's still not that much time. And it might not be enough. All clear time, you're setting to minimize the chance that your alert is going to restart, because stopping and starting the alerts is not ideal. When I take a look at this, I get reasonable values of about 15 to 30 minutes. Going longer than 30 minutes doesn't seem to buy you anything, and going less than 15 minutes starts to bite into things that are important, like your lead time. And so, in general, I think these are pretty good ballpark numbers for you guys to shoot for. So we have some questions. Anna, are you going to do mic duty?
I can be loud.
All right, be loud.
How safe do you find the vehicle to actually be during a lightning storm? We do not have shelter, true shelter at our site. So we're sending visitors to their vehicle to seek shelter or to their homes. But how is there data that supports?
Yeah.
How safe is it?
Pretty safe. So it depends on the vehicle. So if you're looking at the National Weather Service recommendation, they say a hard-topped vehicle. The reason the vehicles are safe is because you're surrounded by metal. And so there's going to be notable exceptions to this. In terms of safe places to be during a lightning storm, surrounded by metal is your best bet. We would call that a Faraday cage. And the reason is that if lightning hits the vehicle, the currents will go around you rather than through you. And the vehicles prove to be quite safe. The caveat there is the vehicle needs to be a metal vehicle. And so if you have a Corvette, which is made out of fiberglass, that's not so true. Or if you have a convertible, which doesn't have a metal roof, that's not so true. So for the most part, going to a vehicle is definitely good advice. If you're gonna go to a not vehicle, you're gonna go to a shelter, and you're going to look for the best place to be. Number one on my list of things that a shelter should have is a foundation. So like a concrete foundation. Largely because usually those concrete foundations are reinforced by rebar, and so the current going through the ground instead of going through you will now bypass you and go through the foundation, go around the foundation. That's ideal. The next ideal thing to have would be a metal frame. So something like this building would be great. You have a nice big metal frame, it's definitely grounded. Lightning hits the building, you will not be struck. Interestingly enough, most homes don't have that, but what they do have is power. You have electricity in your house, and that acts pretty well at redirecting the lightning current so it doesn't go through you. But that said, in wooden structures, fires are somewhat likely, and so if lightning hits a wooden structure, even if it doesn't kill anybody inside, it can catch on fire.
I have so many questions. Can you make a shelter more lightning proof by adding rods to it?
Yes. So the question there is, can you make a shelter more lightning proof by adding rods to it? In short, you should be able to. The requirement there is not just a rod, but it needs to be a grounded rod. So you need to run a ground line. That ground line needs to be big enough that it can carry the current from a lightning flash. That current is high. It's about nominally 10,000 amps. So a lot more than what you'd get in a house system. So usually those are grounding straps. Relatively beefy things. No, no, unfortunately, a tiki tut probably is not sufficient.
So no in from the bar is what he's saying. You're right, you're right.
Now, if the range is 15 miles and lightning's coming across that 15-mile range, technically we're all at risk because of the upward streams that could occur within 100 miles.
Luckily, no. So you had to be pretty close to the channel for an upward streamer to happen. So I said within a few miles, not within 100 miles. You can have those upward streamers happen without the lightning flash if you're on a mountaintop. So upward leaders are most common if you're exposed. So if you're hiking on a ridge line or something like that, and that's exactly what happened to those boys in California. They were on a mountain coming down, and they're elevated towards the cloud, and that increases the electric field and increases the likelihood of a leader launching off you. Otherwise, you need to be pretty close to a channel coming towards the ground. but it doesn't have to be the channel that hits the ground. And the breadth of a lightning flash is, about 4 miles. So, 15 miles plus maybe another 4.
So aquatic facilities clear the water.
Yes.
Why? No, it should be common sense because you're going to get obstructing the water.
All right, so
But if we have concrete out and around the water, the aquatic facility, should that be enough?
So you're in the water, right? If lightning strikes the water, the current is still going to travel along the surface of the water. Now, if you imagine if you're standing on the ground, that goes up one leg and down the other. If you're swimming, that goes through your head, which is less than ideal. Please.
Yeah, got a little bit of a quandary here. Our friends at HSSA, Florida High School Athletic Association, probably AtmoSFeric objector in there, maybe not one. In their documents, they tell our folks 6 miles clear to stand. So obviously by your graphic there, a little too close for comfort, too close for us. So we fortunately set up 2 alerts. We compromised with the athletic group that we would give an 8-mile warning for athletic events, and we have a 10-mile for elementary schools and everybody else. So we do get complaints about the number of alerts for, because you'll get the 10-mile warning, clock starts, then you get 8 mile, it starts over. So I'm wondering, in your opinion, if we might be better off changing our 8-mile, just eliminating the 10-mile warning for high schools, but then puts our daytime PE, ROTC, and just general folks outside, a little more risk. But it would probably clear up some of our lead time, clear time issues.
So in Florida, all right, so the question is, this is hard for me to answer. The quandary is not an easy one to solve, is the issue. The first thing that I would try and do is to move the activities to as early in the day as possible so that the alerts are less likely.
Well, unfortunately, we play football in August and September from 6 to 8 p.m. sometimes going into
Which is...
on metal stands with big light posted over.
And then, unfortunately, the reality of the situation is there's not much you can do. The likelihood of lightning hitting you is just what it is. You live in Florida in an area where lightning is very common, doing something that is relatively dangerous, and you kind of sort of just have to accept that and act accordingly. And acting accordingly is what it is. You've been hearing from other users here on kind of best practices, and usually it's to have a warning of sorts.
Which is kind of what we're using the 10 miles for in our
Although I'd make it bigger, honestly. The difference between 10 and 8 miles here is only an additional, 2 miles. That's 1.5 minutes per mile. So that's an extra 3 minutes that you're getting yourselves. Is that really enough to be useful? I would be...
I got coaches arguing with me that their guidance body says 6 miles.
Yep.
Making us clear 8.
And 6 miles, I agree, is too short for a school. I mean, if you think that you can get people off of the field in 9 minutes, then great power to you, but I don't see how that's possible.
Right, which is why we would go.
And, the National Weather Service is pretty clear on this. 10 miles is the way to go. I don't have an answer for you.
Well, it sounds like we're doing the best we can.
I think you're doing the best you can. And you should always strive to do better. But I fully understand that, administration doesn't always see logic.
Except for yours.
Of course, yes.
The other thing that you might want to keep in mind is that I have a alarms set up at 30 miles and at 20 miles, and then my horn goes off at 10 miles. But I've watched storms hit the 20 and 30 mile radius and simultaneously. So, you know, you're 10 mile warnings, not that you get on the wall.
Especially down here where they can move up with some
Yeah. And they can pop up over your head.
Especially in Florida, popping up over your head is kind of likely. In Oklahoma, you usually get these frontally driven storms, and so you have a fair amount of lead time on when the storm is going to hit you. And oftentimes that lead time is like 24 hours. You look out, you say, there's a front, it's moving this fast, it's going to get to me here tomorrow afternoon, and you can make that prediction and be correct to within an hour or two. That's not true in Florida. Here, you're going to have a storm that's going to pop up over your head in about 20 minutes and have, very, very little warning at all. Yes, ma'am.
Is 10 mile radius good enough if you're dealing with water and waterfall?
The guiding principle to this is always going to be, if you have a 10-mile radius, that means you have about 15 minutes of lead time, nominally speaking. Can you get people to safety in 15 minutes? It doesn't matter necessarily what you're doing, but that's the fundamental question, is how much time do you need to get people to safety? And that is going to be what sets your alert radius.
And if safety is my car, I need to walk from the furthest point in my facility to the furthest point somebody would park and do
Correct.
calculation that way and determine my radius based on that data.
Yes, and so if you're working with employees, doing things like having different alert radiuses for different people is maybe appropriate. So if you have people that are working very far away and then you have a different set of people who are working nearby, having different alert radiuses for when they should stop work makes sense. The people who are way out there are going to take longer to get to safety.
Just for clarification, you're alerting on an actual strike that's in place, not a potential.
That is correct. So when I did this, I was looking at actual strikes, and I was just replaying the data through. So I was looking at stuff in the past, but I was treating it like real alerts. So when I had the first stroke that came in within the alert radius, I started the alert, and then I kept looking for every strike after that for a long time, looking for one that actually hit the target. And then if there wasn't any within the alert radius for the all clear time, then I'd close that alert and move on to the next. Yeah, Mark.
Is there an argument to seasonally adjust your radiuses?
In Florida, maybe not. In other places, the short answer is I don't know. I've done this analysis right now for Florida for Orange County, and Mark is asking me a slightly pointed question because he knows that I have to do this analysis for him for airports across the country. And apparently, I now need to do it for him for airports across the country seasonally. I think so. I think that's me reading between the words. I don't know. It seems likely that there would be, even in Florida, actually, I shouldn't say that, because in Florida in the summer, a lot of your weather is driven by these pop-up storms, but in the winter, you're getting a lot more frontal action. And there's a pretty good reason why you might think that they're going to act differently. Anybody else?
Like on the all clear statistics, right?
Mm-hmm.
Is the application specific to, in other words, or is that just really, because it feels like it's not?
I suspect that the trends are not location specific for any of this. So, increasing alert radius will increase your lead time, and increasing and your all clear time is going to be essentially minimizing the chance for the storm to restart. That's going to be true everywhere. What's going to be different is how much lead time do you get per mile of radius, and what is a reasonable all clear time? Yeah.
With all clear time, not to cheat the system because 30 minutes is 30 minutes, but are we more likely to see lightning ahead of the storm, within the storm, and less likely at the back of the storm, so when it passes, I can get a sense of relief? Or do I still need to be on guard for that strike out of the...
It depends. The answer is 30 minutes is 30 minutes. We'll start there. But in terms of whether or not you're likely to see more likely to see stuff after the storm or before the storm and so on, it has to do primarily, so the biggest thing is going to be the direction of the anvil. And the direction of the cloud and the direction of the anvil are not the same. And so sometimes the anvil is going in the direction of the storm, and sometimes the direction of the anvil is going behind the storm. And in that anvil, you have a bunch of charge. And you get a lot of flashes coming out of that. And so to begin with, if you're under cloud, then you're definitely not safe. And trying to figure out the direction of the anvil without a meteorologist on hand is maybe a little bit difficult.
Well, to be specific, we have a 12-mile alert, so it's safe to go back into the water after it goes out of 12 miles. But 15 miles, if I still hear thunder, I should be indoors. But if it's moving away from us and it's past our 12-mile point, which gives you the ability to go back outside at our facility, or we may have to modify that, there's a sense of, hey, we're okay now, but we're still within that 15-mile radius. So are we actually okay?
Well, you're never actually okay.
Probability speaking.
Probability speaking, if you can hear the thunder, you're too close. We'll start there. Even if the strikes that are being located are more than 12 miles out, that doesn't necessarily mean that you don't have channels that are closer to you that we're not locating for one reason or another. Because remember that strike, that point that we give you is not the size of the flash. And especially when you're under cloud still, if you're hearing thunder, that's coming from the channels in the cloud. And so if you're still hearing thunder, it's probably not okay.
The challenge is it's beautiful, sunny right out above us, all around us, but outside that 12-mile range. So it's just one of those topics of conversation you're having with a visitor, and you're explaining to them safety is number one. We are waiting until we get a 30-minute all clear, and they're like, but it's sunny out. And so it's just that idea of, listen, strikes can happen at any time, the same concept.
And
but I wasn't sure if it was passing, or it was less likely.
No, and especially for those bolts from the blue, I had a friend who did a lot of time studying them, and I asked him, what kind of storms are most likely to produce them? What direction do they go? And he said, so far as he can tell, there's no preference, that they will go out of the storm in any direction, and they don't have a preferential direction. So it doesn't mean that just because the storm is past you does not mean that you will not get a bolt from the blue coming out the back of the storm, even if you're under clear sky. All right, well, thank you very much.
All right, guys, so Michael was born and raised in Queens, New York. His love for aviation was ignited at the tender age of 10 while on a flight from JFK to Jamaica with his family. He was able to get a tour of the flight deck and immediately fell in love with aviation. He's traveled extensively around the world supporting aviation missions for the Department of Defense, Air Mobility Command, and various charter flights. So needless to say, his 15 years of experience is why he now gets to manage the operations at JetBlue's third largest hub. In his current role, he has the pleasure of navigating his team through weather events that, if not managed properly, can severely impact a wide array of customers, flight crews, ground crews, and aircraft. And as a bonus fun fact, he circumnavigated the globe over 9 times exactly. Wow. Come on up, Michael.
Do I hold this, or am I?
You gotta hold that. And here's the clicker.
Gotta hold a lot of stuff. Right. Hi, good afternoon. I'll try to make this as quick as possible. Am I on? Can you hear me? Can't hear me. So I got to use the mic. Okay, got it. Awesome. Anuj, thank you so much for the introduction. What I currently do for JetBlue in Fort Lauderdale is I'm one of the operations managers on a team of, I think there's 12 of us. And we manage different aspects of the operations. We manage the airport operations, customer-facing side, above wing. Then we have the ground folks, which is the individuals that are loading the bags on the airplane. Then my team specifically is a team that manages the operations center. So it's a room obviously comprised of a command center with computers and monitors and you name it, we have it there. So just to get into it, just to give you a little background here, who is JetBlue? So, excuse me. JetBlue was founded in 2000 with a mission to bring humanity back to air travel. And we operate out of 6 focus cities, JFK being our largest hub, Boston, Fort Lauderdale, Hollywood, where I am down in Fort Lauderdale, Los Angeles, and the Long Beach area, which is the LA Basin is what we call it, and Orlando, which is right up the road here, is one of our hubs, as well as San Juan, Puerto Rico. We have over 22,000 crew members operating over 1,000 daily flights to 100 plus destinations. I believe we're up to 106, if I'm not mistaken. We move around 42 million customers annually. We have roughly about 254 aircraft in our fleet. That's operating those 1,000 flights. And a little industry fun fact, we are one of the airlines that actually do push our fleet the most, so we operate pretty red when it comes to the aircraft, the average utilization per aircraft that we have in our fleet. So you can imagine we're running a very lean and tight operation when it comes to getting aircraft in the air and getting folks on their way where they have to go. And if you notice, 2 of our focus cities, JFK and Boston, both operating about 150 to 170 flights each. We operate into the most heavily congested airspace in the United States of America, in the Northeast. So coupled with that, and then you have South Florida weather and Central Florida weather, it becomes quite a bit of a challenge. So why do we watch the weather, right? So why do we watch the weather at JetBlue for our operation? And it's pretty simple, to be honest with you. The answer is actually safety. That is one of our principles and one of our, one of our values that we have there at JetBlue. You know, it's the first one. So everyone says it's our number one value, but I believe that all 5 of the values that we have are pretty consistent in being our most primary objective value that we have at JetBlue. So why safety? That being the top of it, why is it safety? And to be honest, it's to mitigate injury to our crew members and our customers and damage to our aircraft. The 254 aircraft that we have, if one goes down, that disrupts a good 5 to 10 flights in that one day because we're operating so heavy. So we don't want to take an aircraft out of service, and we definitely don't want a crew member to be fatally injured on the ramp while they're working outside, or a customer for that matter that's actually getting off of an aircraft and we have to walk them through the tarmac. So I'm not going to go through the stats here about fatalities because you guys got that already from the doc over here. You know, he gave us the information already, but it's pretty consistent with what he was talking about in U.S. fatalities. I just had 2 previous incidences where in Newark, Delaware, we had 2 people, not JetBlue employees, but 2 people that were struck by lightning while grilling outdoors. One was found in cardiac arrest and stopped breathing. The second suffered injuries to the chest and leg. Then that was just on August 2nd. Then on July 31st in Wellington, Florida, 6 people were struck by lightning while working on a rooftop. 2 were taken to a trauma center, and 2 were taken to a non-trauma center, and 2 were treated and released at the scene. So as you can see, this is very recent and very real. That is what we have to deal with day in and day out. But one of the things, yes, sir, go ahead.
Just the Wellington thing was a bolt out of the blue.
Was it a bolt out of the blue? Wow, see? So, these bolts out of the blues seem to pop up pretty pretty significantly. You guys are probably going to question what we do as to when we look at our radius and our timing, so I'll get to that in a second here. But obviously, being an airline, we all can see where weather can adversely affect just airline operations. So in addition to injuries, there have been several, and I'm not going to name all of them, there's probably been over 20 or 30 aviation accidents that are stemmed from weather being a major player. So you have KLM flight 4805 and Pan Am flight 1736. If you're an aviation buff, you know that's the Tenerife incident where the KLM aircraft was on takeoff roll and collided with the Pan Am aircraft on the runway because of fog that came over the airport. Incidentally, these two aircraft were diversions from one airport to another because there was a terrorist threat at the airport that they were destined to go to. So these people weren't really supposed to be in this particular airport. So you see where a lot of different factors play into it. Unfortunately, the KLM, all passengers on board were killed, and roughly about 385 on the Pan Am flight were killed as well. But this was due to thick fog rolling in over the airfield and low visibility. You had a saturated airfield, so you had multiple aircraft on the ground in Tenerife at the time because of the terrorist incident at the other airport. And again, both of them, the aircraft that was on takeoff roll, they rotated and slammed right into the other aircraft, and it was a pretty messy experience, unfortunately. And then American Airlines Flight 1420 going into Little Rock out of Dallas, Texas, 11 fatalities on this one, where the weather was moving into the Little Rock area. They were getting the weather from Dallas. There was actually a chief pilot for American that was operating at the time. So a seasoned captain and a relatively new first officer, he was actually operating the aircraft. Weather was moving in. This one, they dubbed it as the bowling alley approach because the weather was coming in onto the airfield. With this particular incident, there were multiple wind directional speeds, so their runway changed twice on them. So imagine they're flying through bad weather. They had a runway. You know, when a pilot flies, we're going from here to here. And then all of a sudden you're giving them weather, then you're giving them a runway change. Their plan is now being distorted because of the impact that's actually happening on the airfield. And funny enough, this weather was not supposed to roll in that fast, but it actually did. They thought they can get into Little Rock before the weather got there, but unfortunately they were a little wrong. And incidentally, on this particular instance, when they touched down, there was one thing that they did not do, which is what they did not set the speed brakes because they were so busy focused on the weather, the runway change, different vectors, trying to get back around the weather to come into Little Rock. So unfortunately, when they touched down, they skidded off the end of the runway. Then on this particular one, American Airlines flight number 331 and that picture is the actual Little Rock incident, unfortunately. Then American Airlines 331 Miami to Kingston, going into Miami on a 737, heavy rain. They actually landed in a tailwind, overshot the touchdown point by 4,000 feet, and skidded off the end of the runway, and the aircraft broke up into 3 parts. And with this one, there were no fatalities, thank goodness. So, as you can see, different scenarios and different outcomes. But this is the primary reason why in aviation it is very important for us to monitor weather. And on top of that, there was one factor that sort of led to these incidences. So in the KLM one, it was due to the pilot not listening to the air traffic controller when he gave him the readout, and the air traffic controller gave him the wrong instruction. Again, busy airport, saturated a lot of aircraft. They're managing, they're juggling a lot in that one moment. On the American 1420 into Little Rock, the pilots were so busy trying to get the aircraft on the ground, they forgot to set the speed brake, which are spoilers that pop up on the wing that sort of slow the aircraft down once they touch down. And on American Airlines, these pilots did not follow the training going into Kingston, where they landed into a tailwind. Although Kingston Tower was telling them, there's a tailwind, so be careful. They said, we're going to try for it anyway, and unfortunately they overshot the runway in bad weather with heavy downpour on the airfield. So this is a lot of human factors involved when it comes to monitoring weather. So it's very important for us to be able to trust the systems that we use. I noticed that when I'm sorry, Mike, right? Mark. When Mark was here and he was showing us the update on Hurricane Dorian, he had multiple tabs up on his screen, on his browser, because there are different systems and different tools that we utilize in the industry that help us make the most appropriate decision when it comes to managing weather. We can't really just rely on one. However, we do have one that we utilize in Fort Lauderdale, which is Earth Networks. That is our primary source that gives us the information, and we go by that one. But we utilize a lot of other external factors to help us make the most appropriate decision. It's having like a superhero tool belt, if you will. So we have a lot of things on our tool belt that help myself and my team make the most appropriate decisions. I have Pete here from Fort Lauderdale. He's one of our safety supervisors. Say hi, Pete. You know, and Pete's always saying, hey, we got the strobes on outside and the horn's going off, but is the ramp open or is it closed? I said, well, right now I'm keeping it closed because if I'm looking at the spheric map, I see that this cell is just going to regenerate, even if it gives me an all clear anyway, but I'm going to keep it closed just for the safety of the crew members from going outside and coming back in and going outside and coming back in. They start getting upset when they have to do that back and forth dance. And then they don't trust the information that comes out of our room. So we have a responsibility to make sure, although the system say it's all clear, no, I'm going to hold off. And lo and behold, 3 minutes later, another alert comes out that the ramp has to close down. So sometimes in those moments, I said, okay, made the right decision there. Okay, great, you know. So, you know, how does Earth Networks in Fort Lauderdale particularly keep us safe? And so it helps us keep an eye on the weather, if you will. So who's looking at it, particularly when it comes to Fort Lauderdale and when it comes to JetBlue? So there are 4 entities, that are looking at weather in order to get our customers from point A to point B safely and to keep our crew members safe on the ramp and at work. So the first one you see here on the top left is our System Operations Center, which is located in Long Island, Queens, New York City. They're monitoring weather impact to the network, which is all stations. So particularly right now, Hurricane Dorian. There's a meteorology team in Long Island City that we've contracted and that does work for us at JetBlue. And they're the ones having the conference calls at 8 o'clock in the morning, at noon, at 6 p.m., because they're getting, once the NWS publishes their data, then they take that information, they run it through their programs, and then SysOps comes and we get on a call and we pretty much go down the list of, hey, give us a status update on all of the the tasks that we have to look at. So we look at emergency response preparedness. We make sure that all of our employees have their phone numbers updated in the database. We utilize a system that once there's an incident. So for right now, we sent out an alert to all of our employees in San Juan and all of the Caribbean islands that were affected from as Dorian is moving, doing wellness checks. So right now we've had a 70% response rate where they're saying we're good, we don't need any support. So that's what our system ops team is looking at, especially when it comes to weather, getting the information out to our teams, making sure that they're reporting back to us any support that they may need, on top of issuing cancellation packages based on the weather forecast that's going to populate, particularly for a hurricane event, if you will. Then you also have us in Fort Lauderdale locally, my team, and the other local leaders that are monitoring the impact to our local station. Particularly, I take it a step further. So I was talking to the folks that I was sitting at the table with. So if I'm on the desk in my ops center, if I notice that, sometimes I just get a little weary sometimes, so I'll just scan out on Spheric and I see that Orlando has like weather. And I'm like, all right, so now I need to plan in the event that flights have to divert from Orlando to Fort Lauderdale because they can't land, which happens pretty often and not. So that's taking it a little, backing it out a little bit so that we can have a better plan going forward. A former boss of mine always told me, he said, proper planning prevents poor performance. So I always make sure that I have a plan in my back pocket so I secure additional gates as needed so that if I get a diversion, I can handle 2, 3, 4 diversions at a time, because I have the gates, I have the ability to support that operation as needed. So we're looking at the weather locally. Locally, we're looking at the weather to ensure that impact to the line of weather that's going to move through us. I think Dr. Mike said it best, where we have 2 types of weather systems that impact us in Florida, pretty much. We have those pop-up storms, so we got it from from the gentleman earlier today, the meteorologist down in Fort Myers, where you got that front, that what is it called? The sea breeze boundary. There it is. So once that's happening, you're going to get that on top of, that's like a squall. So that's it looks like a train line of weather that moves, and we get that more so in the wintertime, and that is one of the most difficult challenges that we can experience here in Florida, because there was a line, I believe, last winter where it moved all the way from like the Atlanta region straight down to like the South Florida region, and it just kept moving east. And what happens with that is it'll hit Orlando, then flights divert to us, and by the time it gets to Fort Lauderdale, flights have to divert. So now it's creating a messy path. We had aircraft taxiing for about an hour and a half, 2 hours on the ground in Fort Lauderdale. I called the tower. I said, hey, what time is flight 511 to Austin going to take off? He said, man, we can't get them out of here. He said the tops are so high on that particular line, we couldn't even route them down to Cuba to bring them back up to go to Texas. So they have to come back to the gate because that line was very long. So, and he said, we sent the test flight out, and they turned back and said, no, we can't make it. So they're going to have to divert somewhere else for gas. So well, that's an unfortunate experience, but that's what weather does. It's like it's pretty much a wall up, and it's just moving from west to east, and that's very difficult, especially when you have aircraft already in the air, and it's not just us. So you have other airlines that are operating into the Florida region. So it's weather can just make it a very tricky and nasty experience. Then you have the pop-ups, the ones that come because the ground is heating up in the morning. So by the afternoon, you're going to get, by 3-4 o'clock, we know alert's going to go off because that's what's going to happen. And those sometimes in Fort Lauderdale, particularly, we notice that they start over the Everglades. Now, depending on the strength of the sea breeze, sometimes I'll get a forecast that'll say, hey, the sea breeze boundary is keeping everything west of the airport in the Everglades. I'm like, yes, this is going to be a good day, because I know that my ramp's not going to close, because it's going to keep everything over the Everglades. It could stay over there all at once, like just linger. Don't come inland. And sometimes it'll or they'll say that sea breeze boundary is going to break up, and then you'll start seeing storms develop over the airfield. And like, okay, here we go. Now we're going to have a bad day. So that's what we do locally on our end, monitoring weather. Then you have our dispatch, which is in SOC in New York City. They're monitoring weather as well, because they're looking at departing weather, en route weather, and arrival weather. A lot of people say, well, if you're flying from DC to Fort Lauderdale, you're like, they say it's weather, but it's great here in DC, and my friends are in Fort Lauderdale telling me that it's great. I'm like, yeah, but if you back that map out, you'll see that there's a thick line right in between those two cities that sometimes you can't fly through, because if the tops are really high, they close down the routes. Think of the airways as roads in the sky. So once the FAA shuts down routes, now you have what's called an airflow program. So if on a good day, you'll have this much range to fly aircraft between it. If weather starts to impact that, now your routes start to close. Now you have to still move all those planes through a more narrow corridor, and that's where you have like what's called a ground delay program in the sky. It's called an airflow program. So the FAA will implement that, and then all of a sudden your flight gets tapped with a 3-hour delay. But the weather's great here and it's great there, but there's timing, and we can't according to the FAA, we have to delay out all these flights. And it's not just us, it's American, it's Delta, it's everybody that's operating within that route to go, especially up and down the East Coast. So dispatch will run their flight plans. They'll look at, hey, what's the best route? Sometimes you'll notice if you fly frequently that you may have to be routed. If you're coming from New York to Florida, you may go more inland to come back around to the back end. And now your flight is like 3.5, 4 hours. Like, it took me 4 hours to get from New York to Florida. That's because those routes were closed, and that's the best option to get you down to where you got to go, to get to where you got to get to, instead of canceling your flight or delaying you even further. Because once we start delaying flights, we eat into crew duty time, and now we're going to have cancellations because pilots and flight attendants do not like to fly past their scheduled time of how many hours they should be working. So there are a lot of factors when it comes to aviation and how we have to manage it, because if we're not looking at the crew duty time, now with FAR 117, pilots have to have a certain amount of hours of rest. If they don't get that, if they don't take off, there's a new thing now where if they don't take off and arrive into a destination by a certain time, then they will go back to the gate and they'll say, nope, or if they choose to extend, then they can go, but more than likely they'll probably say, no, I'm not going to go. We'll go back to the gate. And then you have 150 angry people because, they chose to go back to the gate because the FAA regulations stated that that was needed. And that stemmed out of the Colgan crash in Buffalo because those pilots were commuting and then they worked and then they were fatigued and they also had lack of situational awareness. So now you see how weather sort of impacts us now to 2019. And then our pilots, again, they're looking at the weather where they are. They're doing the same thing dispatch is doing. Sometimes they'll say, we'll take an extra 10-minute delay, but I need about 2,000 more pounds of gas because I may get to where I'm going, but I might have to hold. I was actually flying back to Fort Lauderdale on Tuesday from New York, and we were in a holding pattern for about another 30 minutes because the weather cell moved right over the airfield. Thankfully, we had enough gas to keep circling, and then once it cleared out of the airfield, we were able to go in because the airport said we can't take you right now. So we held over like a little west of the Bahamas area, right over there. But those are the 4 entities that are monitoring the weather, on top of the FAA that's looking at it as well. So you can see there's always eyes on the weather when you're putting airplanes in the sky and you're getting folks from point A to point B. So on this particular instance, this is Thursday, July 25th. I had just came back from Barcelona, Spain on vacation for a week. And this is my first day back. And I step into the office, have a quick meeting with my boss. And then I start getting all these alerts on my phone, like, what is going on? And all of a sudden, it's the storm from hell, pretty much. On this particular day, and we'll get to the aftermath, but however, prior to this event, our team was already engaged, making sure that everyone is updated that, hey, this is probably going to happen to us, because we get early forecasts. So what'll happen is, locally what we do is we send out a weather alert notification to the station. And we'll say, hey, team, please be advised. This is what's about to happen for tomorrow. Please monitor your staffing. Please make sure. And we send this to our business partners, so wheelchair attendees, catering companies, the catering company that caters our aircraft. We're sending it to the fueling company that fuels our aircraft. We're sending it to the cleaning company that clean our aircraft, saying, hey, and we're also sending it to our customer service managers, our ground operations leaders, and my team, and the team that I also oversee that moves the aircraft from one place to the next with those little giant tugs that sort of grab the nose and pick it up, because we got to make sure that we have the staffing in place, because once this hits, nobody's going to be able to do anything. The recovery is what we're going to need the staffing for, because now we're going to have more airplanes at one time on the ground. We'll utilize 3 extra gates that were not planned for. We already have 14. Now I'm going up to 17 gates. I'm going to need a lot more support on this recovery. So on this particular event, the notification, we got a forecast that indicated an upper level disturbance for the 25th that would bring scattered showers, heavy downpours, thunderstorms to the area, after 2 p.m., lasting until 11 p.m. No, that was noon. Then at 3 o'clock that same day, the alert goes out to the station goes out from the ops center advising all teams of the forecast. And hey, at the bottom it says in the green, it says, monitor your staffing levels. Because once we send this out, you should know it's going to be a nasty day. And this is 24 hours before we know that this lightning and this weather event is actually going to impact us in Fort Lauderdale. Then, the day of the event, and I think there it is. The day of the event, 6 o'clock in the morning, we get another forecast still indicating that this disturbance is going to bring scattered showers from 2 to 11. Then at 10:30, every morning we have a 10:30 briefing with our teams. So we advise them, say, hey, FYI, we've sent this out. Make sure your staffing is covered. This afternoon is going to be quite challenging because we're going to have a weather disruption in IROP. At noon, an updated forecast indicates that the thunderstorm development picks up after 1, so it moved from 2 to 1 along the sea breeze boundary, overhead and just inland from Fort Lauderdale. Expect intermittent to scattered thunderstorms throughout the afternoon, finally calming down by 10 p.m. tonight. So it moved from 2 to 11 now to 1 to 10. So now we have a time frame. Okay, we know exactly we know that this is going to hit us at this exact time. Rain could be heavy at times alongside frequent lightning and any thunderstorms that pass overhead. Then, at 1:01, our ramp went under caution, suspending fueling operations 5 miles, 10-minute intervals. And then at 1:16, our ramp was closed and everybody had to leave the ramp because we had an alert within 3 miles with 10-minute intervals. So just to break that down, I know we were just talking about the National Weather Service and the intervals. And so at JetBlue, our lightning strike monitoring is within 3 miles, we stop everything and we monitor 10-minute intervals from the last strike. 5 miles we monitor as well. We suspend fueling at 5 miles. We still load bags on the airplane, but we suspend fueling once there's a strike within 5 miles. And I've asked, why do we split it up that way? It's our safety department in New York, the team that I used to work for, that we sort of came up with that as the best identifier on managing this type of phenomenon, lightning particularly. What we did was, and so somebody asked a question earlier, and I wish I can just say it, but I said I'm gonna wait till I get up here to do it. So one of the things that you would want to do, which is very important, is what we did at JetBlue is that we did what's called a risk analysis. And we identify any organization when managing this type of risk. It's easy to say, hey, 10 miles, 30 minutes and go. But at the end of the day, that is gonna impact the business. So we have to be able to effectively keep folks safe and still manage the business, and you'll see why after I get through this part. So what we did was we brought it to all the work groups, vetted it, flight ops, in-flight, safety, technical operations, airport operations, system ops. Everyone pretty much had a hand in this and said, what's the most appropriate way to manage this? And the one question we always asked was, well, what are we gonna monitor? Cloud to ground, or cloud to cloud, or in the cloud, or whatever that is? We're just gonna monitor everything. And the reason why is because we've asked a question, and maybe Dr. Mike can give me this answer. We said, what was the probability of a inter-cloud strike going from inter-cloud to ground? And everyone that we pretty much asked said, you're gonna have to give me some time to get you that information, because that's just a lot that, like, there's no real statistic, and correct me if I'm wrong, that can identify when it goes like, okay, it's all cloud to cloud, in the cloud, it's all up there. But what is the probability that it'll go from up there to down here? 10%. Okay, so that 10%, he got the number, so 10%. That 10% for us is what we utilize to help us determine how we can keep our crew members and our team safe on the ramp, and our customers that have to walk out there as well. So at 1:16, our ramp was closed because we had an alert that was within 3 miles in 10 minutes. And I think, do I hit play? Yeah. Perfect. So as you can see, that was Fort Lauderdale at the time of the event. As you can see, this spanned from 1 p.m. until about 7 p.m. And now we're getting into the 7 p.m. hour there. So I don't know if you can see it, but pretty much this cell moved through us, and it pretty much caused some major disruptions. So during the event, our team sent out a local ramp status communication to all the employees and stakeholders saying, okay, ramps closed, and then we also update every 10 minutes the ramps closed. More than likely we'll say, ramps closed. The way I do it is, we're gonna be closed for another 30 minutes, because we know that the way it's just sitting there, it's not gonna let up anytime soon. So 30 minutes, and we're also advising the pilots on the air to ground. On top of this, now we have to identify how long is this gonna sit here? And based on the forecast, and just based on the way it just kept billowing, it just kept going like it was a monster, like it became the Hulk and just sat over Fort Lauderdale for all this time. And we said we had customers on an airplane that were already boarded, so they were getting ready to depart. And we're like, you know what? Take them off. And so now we had to deplane 5 flights that are at gates, full, 150, 200 people on each plane. Now the terminal gets oversaturated because you have people that are waiting to depart. These people should have been already gone. So now everyone's just coming back into the terminal. The concessions are getting full. The bathrooms are getting full. So it becomes a very, very nasty experience. I'm sure raise your hand if you've ever been through that in an airport. Yeah, it's not my fault. So, so radio announcements are made advising employees and stakeholders of flight crews of the ramp closure. A lot of talking, a lot of communicating. Passor updating indicating our ramp is closed. There is a tool, and there's a misspelling, and I'm a little bothered by that. I didn't catch it earlier. There's a tool that we use in Fort Lauderdale by the airport authority. It's called Passor. Passor allows us to talk amongst all the airlines and the airport stakeholders in like a chat. And so in my ops center, I have a team of 5 7, excuse me. I have 2 supervisors and I have 5 coordinators and 2 IDS, or what you call informations crew members, that are communicating, pastoral information and communicating with the county, getting gates as we need it. So they put in the little chat and they say, okay, if a JetBlue ramp is closed, and they'll indicate closed in the box. So they're also updating the airport authority and all the airlines in the airport and telling them, hey guys, our ramp is closed, FYI, because it's going to be a nasty little day. Then the local ops team implements the recovery plan by reviewing crew duty time. As we said, duty time is very important here in the industry, and local CBP closure time to formulate priority departures once the ramp reopens. Now, I say it's local CBP closure time because in Fort Lauderdale, if you've ever flown internationally, our CBP FIS, Federal Inspection Service Center, closes at 11 p.m. So if my airplane is not in the gate, blocked in, and customers off the airplane by 11 p.m., customs will say, your plane can't come here, you got to send them somewhere else. Fortunately, I think they like me, or must be a really nice guy, or I'll probably have my mom cook for them at some point. They actually stay open for us when we ask. So they'll push in and say, you know what, midnight 30 is the latest. That's it. So I got a good hour and a half to play with. Now in the afternoon, if once this event hit, I still had about 3 or 4 international departures that had to leave Fort Lauderdale, get to the international city, and then come back before 11 p.m. It was Kingston, Mexico, Port-au-Prince, and Grand Cayman, if I'm not mistaken, and Havana, excuse me. So those are the 4 flights that I know have to get out. And again, I know my job, so I'm like, God, I got to watch these flights, because if they take a delay out of Fort Lauderdale as you recover, now we have to worry about the back end of the aircraft coming back. And if Customs says we're not going to stay open, or if that delay pushes past 1, that flight will eventually divert to Miami, which is only 30 minutes down the road, but it's just a bit more challenging. The customers have to clear immigration there in Miami, Florida, but they bought a ticket to go to Fort Lauderdale. Better than canceling the flight, at least you got back, but it's very difficult at times to tell a customer, hey, this is the better option because of weather. But that's what we have to look at. And we say crew duty time because, again, we have to make sure that these flight attendants and pilots may have started their day earlier in New York. Our flight attendants will route Newark, Fort Lauderdale, Boston, Boston back to Newark. Now, if they get to Fort Lauderdale and they're delayed 5-6 hours, that's going to impact their duty time. They may get to Boston, but they won't be able to come back to Fort Lauderdale. So now we have another challenge on our hands. Technically, it's not my challenge because the airplane's going to be in Boston, but that's how that works. It's the system operations challenge. Our job is to just get it going so that we don't have to deal with a more crippling operation in Fort Lauderdale. And then the recovery plan is communicated to all work group leaders. And so when an international aircraft comes back in from Fort Lauderdale, we have the responsibility of repositioning it from the international terminal to the domestic terminal. What happens is, if the ramp is closed, my personnel are not outside. So the aircraft can come into the gate. We have a system called SafeDock visual guidance system, where once the ramp is closed, we advise the pilots, once they touch down, the ramp is closed, you're going to come in under SafeDock with no wing walkers, nobody to watch your wings. And we'll set the system from the ops center. They come in, jet bridge gets attached, customers are coming off the airplane. However, your bags aren't coming off the airplane because no one's outside to take them off the airplane because the ramp is closed. But again, at least I can get you off the tin can and into a facility versus sitting on an airplane for an extra couple of hours. I had a flight a couple years ago when I first got to Fort Lauderdale. It was a Cartagena flight. Flight time from Cartagena is 2 hours and 34 minutes. They sat on the ground in Fort Lauderdale for 3 hours and 36 minutes. Longer than their flight time from Cartagena, because of the impact of the weather that we had that day. So when you put it in retrospect, it's like they sat on the ground longer than they were in the air. Like, yeah, that's pretty much how that happened. And DOT rules dictate any flight that's a domestic departure has 3 hours. I have to make notification to say, your gate is this, come back to the gate. And then it stops the clock because of the incident that happened in Bradley not too long ago. Then on international inbound, it's 4 hours, so I got an extra hour to play with. But we try not to keep folks out there that long. So we sort of have a contingency to just have aircraft wait for the gate. We'll bring you in based on how long you've been sitting on the ground waiting for that gate to come in, and we'll know that within an hour or so. So after this particular event, it spanned 4 hours and 18 minutes in Fort Lauderdale. 4 flights diverted to nearby cities. 2 went to West Palm Beach, 1 went to Fort Myers, and 1 came to Orlando. 23 flights were delayed more than 3 hours in the afternoon. 12 flights were canceled after the scheduled time of departure. Majority of them were those flights that were already delayed 3, 4, 5 hours because of this weather impact. And multiple flight crews were timing out because they had exceeded their duty day limitation because of the time that it took for this cell to sit on us. And 1,200 passengers were impacted as a result of the live cancellations that night. I didn't leave work until about 2:30, I think 3 o'clock in the morning. And when I'm walking out of the terminal, I still see customers at the ticket counter being rebooked for later flights on another day because we've had to cancel all those flights. Those flights were canceled because the flight crews exceeded their duty time. The flight attendants were calling fatigue. It was just a messy, messy experience. And this is all the result of a 4-hour and 18-minute weather system that sat on the airfield for that long. So in aviation, we have a lot to look at when we're juggling these types of events. We have to look at the crew duty day. We have to look at the aircraft routing, specifically the routing, because your aircraft, let's say you're going from Boston to San Diego, your airplane is probably in Fort Lauderdale stuck in a ramp closure. So that's why you're delayed. And chances are, if that same flight crew is operating Boston to San Diego from Fort Lauderdale, and they exceed their duty day, you're probably not going to make it out of Boston to San Diego. So now our system operations team has to work to recrew that flight or swap it to another aircraft that's in Boston to keep it going. So now you're pretty much pulling up. You're just playing whack-a-mole with airplane and people to keep the operation flowing and going. And it's not easy when you have to make these decisions and try to explain it to the customers and say it's due to weather because they think that you're just lying anyway. So, and then we've been talking, so how do we make sure we allow our customers to see that it actually is weather? And we're gonna be installing some screens at the baggage area, the gates, and the ticket counter as well, with the Spheric going, so they can see the actual weather system that they're going to be experiencing, and not that we're just lying to them because, it's just Mother Nature. But that's really about it. That's how we navigate these events. Now, this was a not so good event because I want to highlight that this is just a 4-hour and 18-minute closure. The longest I think I dealt with was 4 hours and 24 minutes, but that was like 2 years ago. Since we've gotten the Spheric outside of this event, we've actually reduced the number of cancellations that we've had after these events. We're actually able to recover quicker. I can't remember which day it was because these happen so frequently in Florida. But there are days where I'll come in and I'll have a 3.5-hour closure. But we recover just like that because we're already ahead of the game and ahead of the curve. It also depends on how the system is set up, because in addition to the cell impacting the airfield, it will also impact the routes. So what also hurt us on this particular event was that we had the diversions. Now you have an aircraft coming from Havana to Fort Lauderdale that now has to go to Newark, New Jersey. But the airplane is in West Palm Beach, and we don't know what time it's going to get out of West Palm Beach to get to Fort Lauderdale until I clean up the Fort Lauderdale operation to even have a gate available for when they touch down and get into here. So it's a lot. It's like it's a puzzle, and you have to make sure how the puzzle works. There are times that flight crews will say, "Well, we're timing out in West Palm Beach." Okay, so now you have people in West Palm Beach that are coming from Havana, and there's no customs. So what do you do now? Those are the scary experiences that we sort of have to work through to keep it going. Our team in West Palm Beach, I know, utilizes this system as well from their regional. So I know that everyone's always looking at it, but sometimes it's also based on the decision that flight crews will make on actually accepting to continue to go because of the weather. But that's all I have. I didn't know if I went over time. No, I'm good? Awesome. Questions, answers, comments? Yes, my dear.
So your critical load 3 is 3 miles.
Yeah.
So when you did this analysis, you found, according to Mike's metrics here, that you could clear the ramp and stop operations within like 5 to 6 minutes?
Yep.
Okay. So that radius wouldn't necessarily be helpful for other types of organizations, school, very players off of the field.
Because you got to get a lot of children. Yeah, so and that goes with Dr. Mike's theory as well. You're absolutely correct. When we did the risk assessment, because of the proximity of the ramp to the break room area, it's like that. So it's literally all radios, please be advised, the ramp is now under caution. All radios be advised, the ramp is now closed. Literally within minutes, the crew members come off. On top of the fact that we have the horns and the strobes in Fort Lauderdale, that will go off as well. So once they hear that, maybe 5 seconds later, they're going to get the radio announcement, and they know, okay, it's time to clear, and they just walk off. In Fort Lauderdale, and I'm glad you showed the Sun Country incident. I was going to have it up there, but you stole my thunder. See what I did there? No, okay. That Sun Country incident is very important in the aviation industry to understand, because it hit the tail of the aircraft, went through as he was pulling out the headset from pushing out an aircraft, and so. Let's say, and again, all airlines are different when it comes to their parameters on ramp and lightning radiuses and closures. I know Southwest in Fort Lauderdale is 8 minutes, 3 miles, 8 minutes, 5 miles, 8 minutes, the same number of time as well. So they believe that they can get their folks off the ramp within that time frame of a 3 mile radius, in a 3 mile radius, and then it'd be back open as well. But yeah, we clear it out in about 5 minutes once we actually make that notification. Anybody else? Okay, you all don't yell at me at once. It's cool. Hey, Mike. That's a great question. So our primary threat, obviously, in Fort Lauderdale is thunderstorms, hurricanes, and the like. In Boston, it's in the Northeast, it's snowstorms and that. It's the hurricane of the Northeast is what I call it. So they utilize the systems from SOC to sort of help them make decisions, and they have some other products out there that's not streamlined to the organization. We in Fort Lauderdale have been using Earth Networks for quite a while, and the other thing, to be honest with you, is the team's ability to know how to navigate through thunderstorms. You know, I have a manager now in Fort Lauderdale. He came from JFK. This is his first hurricane experience that he's about to go through. So he's asking the questions, you know, so what are we supposed to do? How do we make sure we notify the crew members? And that's because 2 different operating platforms, so they're going to utilize 2 different tools. System ops, because Boston and JFK are the largest city, system ops, any impact to those cities is going to hurt our network severely. So SysOps stays on top of them. There's days where, you know, sometimes they're not looking at Fort Lauderdale, so we'll have to say, hey, Earth, we're getting this forecast, and that's what I'm seeing on Earth Networks. And they're like, oh yeah, let's get somebody to get a quick forecast going as well, because they're so busy with the Northeast, especially if you have ground delay programs and the like up there. Any other questions? No? Going once? Twice? All right, thank you guys. Thank you so much.
All right, everyone, that concludes the sort of sessions. Now we can move on to some of the fun. So the bar is open and the rides are ready. So we're going to basically take down the tables and get happy hour started. So if you can take your bags with you to the back, that'd be great. And then grab a drink and grab a ticket, and you guys can head up over to the wheel.